Good to be here. Thanks for organizing this. What I want to do is talk a little bit about how we've been experimenting with these various large language model technologies and trying to wrap our head around ways that we can incorporate this well into mathematical education. And so, really, I'm just going to kind of show a very quick demo of kind of some of what we've been experimenting with, and I'm very curious to hear other people's experiences in their classes, best practices, maybe some ideas related to pedagogy, and so on. Um, so let me just see. Okay, there we go. So I think, it's important to point out that the sort of status quo is that kind of no matter what we do in our classes, I think it's pretty obvious that the students are going to be going out there online, using all of these large language technologies. And I think really in many ways, at least what I would like to do in my classes is have enough experience with these things, or at least pooled knowledge that I can kind of guide them towards the best resources and maybe the best practice use of these various techniques. And so I did a little bit of research on what AI tutors are currently available for mathematical courses. And I should maybe give a little bit of background. What we have at UCSB is often very large undergraduate mathematics classes that are basically supporting a very wide range of STEM fields. So people that are doing their majors in the various sciences, statistics, mathematics, even in some cases engineering. So these end up being like 400 student classes, many different backgrounds, large like lecture format, things that are in like Campbell Hall, for example. And so you can't really have that immediate one-on-one kind of interactive experience with individual students, kind of figure out where they are, or even help them in office hours, given basically the scale of these classes. So we do break them down into smaller sections that are run by TAs, but that's rather limited contact during the week. So I'm kind of trying to look at ways in which maybe some of this technology can be leveraged as like a more scalable solution to try to reach a broader set of students and in some sense offer like 24/7 help when they're getting stuck on homework or when they're confused about concepts. Now, of course, with all that said, we know LLMs have a lot of limitations currently. They kind of make up explanations and so on. So the question really becomes like, how do we, best leverage the current state of this technology and make our students aware of those limitations? So that's kind of what I'm hoping to get a few suggestions and hear people's thoughts about in this discussion. So I went through and again, kind of did some quick research on different tutors that are being kind of pushed out there in the marketplace. So it's really towards the bottom of my list, this mathful.com, SymBioLab, MathOS, Julius, Mathway. There's like a very large number of these LLMs that are being marketed out there. And then what's interesting is a lot of these more dominant LLMs like Google Gemini, things like ChatGPT, I've noticed are actually on the back end sometimes interfacing with these tools because you can audit the LLM and say, well, how did you come up with this particular answer? And sometimes it'll actually tell you the link. Oh, I ran this through Mathway, and then I took the output and I summarized it for you. I'll focus primarily on Google Gemini, but I also wanted to point out that there are other interesting math resources that are maybe a little bit more in the traditional category, like Wolfram Alpha, if you're familiar with that, or packages like Mathematica, SymPy, and so on that have traditionally been used. But the challenge often for students is you have to write this within a very precise mathematical scripting language or use it in the context of a programming language like Python. So I think one interesting use case of this technology is it becomes kind of like a natural language interface to some of these well-established packages. And when that's the case, I think we have a good hope that the back-end answers that it's giving could have some level of robustness relative than just simple pattern matching from some previous worked out calculus problems. Okay, so with that in mind, I did some experiments with Google Gemini, and kind of the questions that were in the back of my mind is, how can we incorporate this well into these large lecture classes? What might be some good best practices, especially since we know LLMs have these limitations? And I'd be curious to hear at the end other people's thoughts about the proper roles this technology might play both in pedagogy and in assignments to students. All right, so I'll kind of jump into that now. And I should mention that the Google Gemini UCSB has a lot of infrastructure to support that, and I believe a subscription. So that's probably going to be one of the most immediately accessible ones. There are more educationally curated technologies coming on the market, like Khan Mingo, which is associated with Salman Khan's Khan Academy that I think a lot of people are familiar with. And the idea is these LLMs have a lot more guardrails and almost engage in like a Socratic dialogue with students to guide them towards answers. So that I think would be another great option. But that does have a subscription model, at least for college students, unless the university were to subscribe to that. So I'll focus on Google Gemini, but a lot of what I say I think will equally apply to some of these other techniques. So again, you don't have to know calculus to kind of follow this particular experiment, but I just want to demo for people that maybe have not tried this out yet, what you get from one of these prompts. And I should caution that what's really important when you use these LLMs is the actual prompt that you use. If you just say, hey, give me an answer to this question, you'll often get a 1 or 2 line response with the result. So I think one of the things we should be trying to teach the students is, hey, when you go and use an LLM, design your prompt so that it's informative, not just about the final answer, but the kind of process by which that answer was arrived at. And so what I wrote here was, compute using the chain rule. So I gave it a hint about the way it should do it. Show me each of the steps for computing the chain rule of this particular function, f of x sine of x squared. And so as you can see, it gave actually a quite nice high quality answer. It basically tells the student, okay, you got to identify this inner and outer function. This is kind of the way that people in calculus would think about how applying the chain rule. It appropriately identifies those functions, f of u here being sine, g of x being the x squared term. It composes it correctly. Then the next step is to differentiate these different pieces. And then it gave me kind of just those 2 steps, right? So it didn't actually give me the final answer. So I said, okay, show me the final derivative, basically, with the steps. And it went through a lot of details, which I'm not going to copy to the slide here. Showed me a basically bullet pointed 1, 2, 3, 4, 5 all the way through, and then gave me the correct final result. So I thought that was pretty, pretty promising, because it's not just giving the student the final result, but also kind of the standard processes, a little bit referencing what theorems or lemmas might be important for them to use in arriving at that final result. So I think that's really the way, at least in my mind, this could be incredibly useful, as kind of a way to get suggestions or hints, especially when someone's very much stuck. I also audited the LLM, I'm not showing that here, on the back end, and I found that in fact what it was doing was taking my expression, writing a Python script for SymPy, running it through SymPy, taking the output, and that was an important part of how it was constructing the answer. So if that's the case, SymPy is a well-established symbolic integration and differentiation package for mathematics, and obviously calculus is part of that. And so I think that if that's the case, and you can audit that, that would be, again, leading to quite robust answers. So again, it's not just simply kind of hallucinating or pattern matching in the general literature out there. If it's a natural language interface on one of these instruments, I think that could be quite useful. So then I decided to give it a much harder problem where I don't hit at all about what the particular lemmas or theorems involved would be. So I'm like, okay, show me the steps to get the derivative of this x squared over sine of x. And so at this location, x equals 0. And so for those of you that are a little more mathematically inclined, you'll realize that I'm basically going to get something that looks like a division by 0 issue, because sine of 0 is 0, but I have a 0 on top as well. So that's a little bit subtle. Like, what do you do in that case? Of course, that's well known in calculus that you can either use L'Hopital's rule if you just want to do the evaluation. You're going to see that 0 over 0 problem also arises when computing the derivative. So I intentionally asked for the derivative because that's going to be a multi-stage process that you have to go through. And so this is the response of the LLM. It basically correctly identified that the first thing to do would be to compute the quotient rule, gave the details of the quotient rule, as you can see there. I'm not going to read the whole response quite involved in detail, but it gives a reasonable answer. It notices that, or it shows you that this would give 0 divided by 0, obviously indeterminate, realizes that the appropriate lemma should be L'Hopital's rule, goes through, explains basically how to apply L'Hopital's rule, and after a little bit more discussion of computing those intermediate calculations, actually shows you what the final limit is and gets the correct answer. So again, I think if you have a prompt that says show you the steps and you get this level of detail in terms of the process to arrive at the answer, that's very promising, because you could spot potential flaws in logic or in intermediate steps that are incorrect in the LLM, but the student would still get something out of that, which is, oh, you know what? I need to apply quotient rule plus L'Hopital's rule. So my thinking is, even if this technology is imperfect, there could be interesting ways which it stimulates and still supports a student's understanding. a little bit as if like the student itself were tutoring a friend. That's often a really good way to learn the material because you start asking yourself questions that maybe you weren't initially motivated to ask on your own, but as you engage in some type of interactive process, sort of become stimulated. So some other fun things you can do with it. Obviously, you can try to create some humorous slides or materials for your class. So I decided, let make an action movie for L'Hôpital's rule. And so we see that when the limit doesn't exist, you make one, or the limit is just the beginning. But in all seriousness, I decided, okay, let's say I wanted to make a nice poster on the chain rule. So I was like, all right, make a poster. And this is where you really see these LLMs kind of go off the rails in some sense. And so if you notice very quickly, it kind of looks superficially like a good mathematical poster. But if you look at more detail, you get kind of some pastiche of mathematics where it sort of grabbed a bunch of stuff that sort of looks like the beginnings of the chain rule, but not really if you look here. And then similarly, you get down here, all these arrows and things that you would normally see when someone's discussing the chain rule. But frankly, it's basically a bunch of nonsense down there, right? So I think we have to be really careful about that. And so I decided to dig a little bit deeper. And I was like, okay, well, what about taking something simpler than mathematics? Like make a diagram of a dog with some labels. And this is what you get, right? So there's the eye of the dog, apparently. There's the paw. You can see the muzzle, right? So I think this really illustrates that these LLMs are really good at producing language that when we project things onto that language does fine, or if we are able to interpolate in language does fine, but it really doesn't have baked into it at least good relationships between the sum and the parts and things that you would expect more logically in giving responses. So I think we really have to be cautious not to impute too much to what these LLMs are kind of doing under the hood. So I did another example to make a poster again on the chain rule and also failed the second time. This one, I think I used the pro version that said it had kind of a math mode. But as you can see, it just kind of created this pastiche of mathematical formulas and phrases that sort of look right, like outer, outer, inner. I have no idea what that collection of arrows is really supposed to entail. And then again, in the pro mode also said, hey, make a bicycle and label it. And so apparently that's the seat post clamp. That's some, I think, made up word there. And then down here, that's where the chain is. Okay. So again, you see this issue where it's good at kind of saying, okay, the person wanted something kind of associated with a bike. So let me make a picture of a bike. It wanted it labeled. So let me just take a bunch of bike words and just throw it here and label. But it doesn't have that deeper structure of the concept of a bike or how the different parts of bike relate to each other. And I think that, again, really, really important to keep in mind when we're using these LLM technologies, especially when we want rigor, precision, and things like that, which is so essential in the sciences. So just as a quick set of summary notes, I think there's tremendous potential here for providing a kind of 24/7 help, but with a lot of caveats. And I think really our job, really the bottom line here is we need to teach students to think critically about technology. And that's not only for the classroom, but this is basically going to be part of what they're going to have to grapple with when they're in the workforce or even when they're in future academic settings doing research. And so they really have to, have this ability, I think, to leverage this technology because it can boost productivity, but also to think very critically about the results that it's getting. I also think it would be important to help students learn about what good prompts would be when they're asking questions, not just give me the answer, ask for step-by-step explanations, ask follow-up questions to clarify steps. So you can really audit the process. And what you're really doing is helping yourself to verify the answer instead of just, oh, the answer is 5, right? Because we have no idea what the process is by which you arrived at 5. And at least in mathematics and a lot of scientific settings, we almost care more about the process than that final number, right? Because we want to know that that number has some kind of guarantees or, some type of foundation or justification. And so I think that's really important for us to be conveying to the students. One of the ideas I have for my class is try to come up with LLM guideline that I can post and give some example prompts and kind of show them, hey, this is the way that's probably very fruitful to use LLMs and this technology and try to help steer them a little bit away from some of those other shortcut type ways that people might be using LLMs. I think also there's a lot of products out there being pushed on students. And so also to try to steer them towards more credible and more academically oriented technologies. In mathematics, we're lucky that we can kind of verify things maybe a little bit more easily than in some of the other academic areas. and again, telling them, hey, it's great to get an LM maybe to give you an idea or suggestion, but at the end you should do some by hand calculation or plug in the expression into a well-established tool to verify that what you got is reasonable. And through that feedback loop, you can enhance your learning. So I think at the end of the day, these are not going to be a substitute for classroom learning, textbooks, lectures, etc. But I do think there's going to be some really interesting potential for enriching student learning, and in some cases, for students that are very interested in this kind of interactive experience, it would be a great opportunity maybe to engage a larger swath of students in the course materials. So I'd be interested in people's thoughts and experiences with these technologies. So I'll leave it there. Thank you.